So the homework from today, starting with 1. We'll do 1a. It's written as f colon x, but it's the same thing as saying f of x is equal to 2x plus 3. So to find f of 0, all we do is plug in 0 wherever there's an x, and it's only the one place. So f of 0 is equal to 2 times 0, because that's what x is, plus 3. So we get 0 plus 3 gives us 3. Next is question 3. A couple more terms, but the same idea. F of x, written as f of x this time, let's do b. F of x is equal to 2x squared minus 3x plus 2. So we plug in a 3 wherever the x is. F of x is 2 times 3 squared minus 3 times 3 plus 2. So 2 times 9 minus 9 plus 2, 18 minus 9 plus 2. I think we can do that now in our head. So 9 plus 2 is 11. On to number 6. Number 6, I'll just leave it here and talk through it a little bit, a word problem. The value of a car t years after purchase, a certain number of years after purchase, is given by the function v of t is equal to 28,000 minus 4,000 times t, or 4,000 per year, because t is the number of years. So find v of 4. This is a function, v of t. So we want to find v of 4. So wherever there's the t, we replace the t with a 4, just like we had done above. And you should get a number, which is the value of the car after that many years. And then b says actually that v of t is 8,000. So the value is 8,000. In other words, we've done this function and the result has been 8,000. It's asking us to find t. So this is the formula to calculate v of t, and this is what we've got. So, without saying too much, but basically it's those two things that go between an equal sign, right? Because this, for a certain value of t, equals that value. So 28,000 minus 4,000 t equals 8,000. So solve it algebraically. And finally, it asks you C to find the original price of the car. Well, there are two ways. You can just understand clearly enough the question that you can see it jumping out at you, or make the t to be 0, because that's when it was originally purchased, t would have been 0. Then number 7 is a graph. We didn't do a question exactly like this, but the point is that you've got the graph, and you can read off of the graph if you've got it, and that's what you're intended to do here. So find f of 2. Well, this is the graph for f of all the x's. So look at the graph and find out the y value, the output value, when the x is 2. And B talks about the output, as it were. saying f of x at a certain point, the y will be 4. So when the y is 4, I'll let you finish it off. What is the value of x? Let's copy and do at least one of these. Let's do C. So we did do this in class. The idea with these, as we saw in class, is that there are situations sometimes where an x value or x values will cause a problem, because you'll have a non-real number, you'll have an imaginary number. So what value of x, or values of x, makes this to be an imaginary number? No square root here, so we're not dealing with negative square roots, we're dealing with denominators that are 0. You can't not divide by 0 and have a real number. So what value of x gives us, or yields us a 0? And it's 3. If x is 3, 3 minus 3 is 0, and 1 over 0 is an imaginary, non-real number. So we write out our domain is x, for all values of x, such that x is not equal to 3. But we better, I don't know if that's good enough. I think that's probably good enough. Try to keep this video short-ish. And we did those in class anyway. But what we didn't do, and we didn't do it, but this is supposed to be a bit of a review, or a complete review from other years. So, and I'm new, I don't know, so let me teach you this and see how you do with it. You're supposed to know, and I think you do, that negative square roots, or the square root of a negative number, is imaginary, and we can't graph it on a number line. It's not a real number. So let's start with A. The question is, as with question 1, how do we make the denominator 0? Now with question 2, what situations will cause the square root to be negative? Well, let's try 2 first of all. 2 minus 2 is 0, and the square root of 0 is 0. So 2 is going to be a borderline case, but anything less than 2 is going to be a problem. So our domain is, as long as we have x values that are greater than 2, we're fine. Right? So, for example, doing the problem, if we had a 1, if we have 1 minus 2, we end up with minus 1, and there is no square root of a negative 1 or any other negative number. So we write the domain as we write domains. Name, domain, x for all x's, as long as x is greater than or equal to 2. But we better do one more that's got a couple of terms. So C. Couple of ways that we can end up with a negative square root, which is not good. Well, first of all, look at the square root of x term. The domain is okay. We're okay as long as x is greater than or equal to 0 for this side. For this term, square root of 2 minus x, well, if we were to go 2 minus 2, we get 0. So 2 is fine. But what else is fine? 1 is fine. Anything in the x which is less than 2 will be fine. But anything that's greater than 2 will not be fine. So let's just write it in terms of domain. Anything where, as long as x is greater than or equal to, or sorry, not greater than or equal to, if we're talking about what's good is anything that is less than or equal to 2. So there we've got the makings for a nice domain of x will be all x's such that x is greater than or equal to 0 and less than or equal to 2. All right, so again, this was just really rough, and I think it's okay. So tell me next class whether or not this worked for you, and that's it.